In February 2019, a team of researchers at Boston University published a study in the journal Nature Sustainability that stopped the scientific community in its tracks. They had spent 2 decades analyzing data from NASA's MODIS satellite sensors, instruments aboard the Terra and Aqua satellites that photograph every place on Earth, up to 4 times per day, at a resolution of 500 meters per pixel, producing the most comprehensive, continuous record of Earth's vegetation that has ever existed. What they found, when they ran that data, was that Earth had become measurably greener, not in the way that climate scientists had assumed, from a warmer, wetter atmosphere accelerating plant growth in northern forests. The greening was concentrated in 2 specific countries. China and India together accounted for 31. 8% of the entire net increase in global leaf area between 2000 and 2017, despite containing only 9% of the planet's vegetated land. China alone was responsible for 25% of the global net increase, a quarter of all the new leaf area added to Earth's surface across 17 years, while occupying only 6% of the planet's vegetated land area. Ramanamani, a research scientist at NASA's Ames Research Center and a co-author of the study, described the finding in the plain language that the data had earned. When the greening of the Earth was first observed, we thought it was due to a warmer, wetter climate and fertilization from the added carbon dioxide in the atmosphere. Now, with the MODIS data that lets us understand the phenomenon at really small scales, we see that humans are also contributing. What those humans had been doing, specifically, was planting trees, billions of them, in places where trees had no business growing. In places where the ground was sand, the rainfall was measured in millimeters per year, and the wind moved dunes the way water moves waves. The project they had been doing it under, the 3 North Shelterbelt Forest program, officially launched on November 25th, 1978, and currently running on a timeline that won't reach its final milestone until 2050, is the largest afforestation program ever undertaken by any government in the history of the human species. And what happened in the places where it worked, confirmed by satellite data that China's own government could not have manufactured or manipulated, was the kind of result that scientists who study land restoration use the word speechless to describe, not as hyperbole, but as a precise description of the experience of looking at a before and after satellite image of a desert and finding in the after something that looks like a forest. By the time you finish watching this video, you are going to understand exactly what China set out to build in 1978 and why, with the Kubuqi Desert, the most specific and most dramatic example of what this program has actually achieved, looked like before the work began, and what it looks like now, what the 2019 NASA study actually found, and what the 2026 study published in Geophysical Research Letters found that surprised the scientists who conducted it, what the honest complications are, because there are real complications, and this channel gives them to you directly, and why the gap between what was expected and what actually happened in the Chinese desert is the most important environmental story that most people have never been told with the precision the data actually supports. Stay with me, because this is a story about a decision made in 1978 that the people who made it did not expect to see vindicated in their own lifetimes, and about what happened when the satellite data finally came in. Let's start with the problem China was solving in 1978, because the scale of it is the context without which the scale of the response makes no sense. China's northern regions, the vast arc of territory stretching from Xinjiang in the northwest through Inner Mongolia in the north to Heilongjiang in the northeast, spanning 13 provinces and autonomous regions, contain some of the most severely desertified land on Earth. The Gobi Desert, one of the largest cold deserts in the world, was advancing southward at a rate that Chinese government surveys measured at over 10,000 square kilometers of new desertification per year at the worst point. At the end of the 20th century, more than 10,000 square kilometers of productive land was turning to desert every 12 months, consumed by the wind-driven advance of sand over degraded soil. Sandstorms generated by this system were reaching Beijing, 400 kilometers south of the desert edge, with a frequency and intensity that disrupted daily life, coated buildings and vehicles and lungs with fine particulate matter, and periodically shut down the capital's airport. The economic losses from crop failure, infrastructure damage, and degraded agricultural land in the affected regions ran to billions of yuan annually. The Muas Desert, the Hork sandy land, the Kubuqi Desert, these were not natural climatic features of the landscape in the way that the Gobi's core is. They were largely the product of overgrazing, deforestation, and agricultural land mismanagement that had stripped the ground cover from grasslands and allowed the wind to begin moving the exposed soil. The land had been destroyed by human activity. The theory behind the 3 North Shelterbelt Forest program was that it could therefore be restored by human activity, specifically by planting enough trees and shrubs to anchor the soil, break the wind, create microclimates capable of retaining moisture, and eventually allow the ecological recovery of degraded land across the most desertified regions of the country. The program was called a Great Green Wall from its earliest days, and the engineering logic behind the name is precise. A wall, in this context, is not a continuous barrier. It is a series of windbreaking forest strips, shelterbelts, planted in patterns designed to interrupt the movement of wind-driven sand across exposed agricultural land, stabilize dune fields by anchoring their surface with deep-rooted vegetation, and provide enough biological material for a soil ecosystem to begin reassembling itself in the spaces between the trees. The target at launch in 1978 was a belt of planted forest stretching approximately 4,500 polar kilometers from west to east across northern China, varying in width depending on the terrain, covering an eventual area of 6 million hectares, 88 million acres, across the 13 provinces and autonomous regions of the program zone. By the time the program reaches its 2050 completion date, it is projected to have created a continuous green barrier approximately 428 kilometers long and up to 1,348 kilometers wide in certain regions, encompassing around 100 billion trees, making it the single largest ecological engineering project in human history by any measure of scale. As of the most recent confirmed data, China has planted approximately 66 billion trees under this program since 1978, according to Live Science's December 2025 reporting, which also confirmed that 34 billion more are planned over the next 25 years to complete the project. The Futura Sciences analysis, published in May 2026, reviewing a 2025 study from Earth's future tracking vegetation changes between 2001 and 2020, confirmed that this collective effort raised national forest coverage from 10% of China's land area in 1949 to 25% by 2024. China began its Afforestation program with a country whose land was 1/10 forested. Today, 1/4 of it is. That shift, achieved in 75 years through a combination of deliberate planting, natural regeneration supported by the planting program, and agricultural land conversion policies, represents the largest increase in forest cover by a single country in the modern era. If you are finding this the kind of coverage that actually goes to the NASA study in Nature Sustainability, the Earth's Future Journal paper, and the Geophysical Research Letters publication, rather than paraphrasing what someone else said about them, subscribe now. This is what every video on this channel looks like, and the subscribe button means you get the next one when it drops. The Kubuqi Desert is the specific place where what the program achieved becomes most concrete, most measurable, and most visually dramatic, and where the description of scientists being speechless is not a journalistic exaggeration, but a description of the documented reaction of researchers who visited the site after reviewing its transformation in satellite imagery. The Kubuqi, located in Inner Mongolia, approximately 400 kilometers north of Beijing, is China's 7th largest desert. Its western sections, in particular, were among the most active and most threatening parts of the desert system, bearing down on northern China's agricultural heartland. Wang Wenbiao, Secretary General of the Kubuqi International Desert Forum, described the state of the desert before restoration began in terms that the satellite record confirms. Mobile sand had been moving continuously. The ecology of the Yellow River Basin was being degraded by the sediment load carried into the river by wind erosion from the Kubuqi's dune fields, and the human population of the surrounding communities was losing productive farmland to sand encroachment year by year. After decades of combined afforestation, sand barrier construction, and what Wang described in a statement cited by the Chinese government's English language portal as follows, about 1/3 of the desert area has become green, with 65% of the area covered by vegetation, an increase of more than 30% from 10 years ago. While the mobile sand has been under control, the ecology of more than 200 kilometers of the Yellow River has been safeguarded. The transformation documented in satellite imagery has been verified independently by Chinese and international researchers and confirmed by the NASA study that found China contributing 1/4 of the entire planet's increase in green leaf area. The Kubuqi is not the only example. The Muas Desert, once described as one of the most severe desertification zones in China, had, by the most recent Chinese government assessments, been substantially reclaimed, with significant portions of its formerly bare sand surface now stabilized and, in some cases, converted to usable agricultural land. The Babusha area in Gansu province and Kekeya township in Xinjiang are cited by China's 3 North Shelterbelt website as additional documented success cases. The Wikipedia entry for China's Great Green Wall, updated as recently as July 2026, cites a July 3, 2026 article in the Economic Times confirming that China has planted 66 billion trees to fight the desert, and that scientists found the planted forests are outpacing natural forests by 66% in growth rate. That last finding, From the study published in the journal Geophysical Research Letters in June 2026, led by Yuhang Luo, a landscape ecologist at Peking University in Shenzhen, is the one that produced the most discussion in the scientific community in the year of its publication, because it was not the result that anyone predicted, and because the mechanism behind it raised questions that the study itself was candid about not yet answering. The researchers found that trees planted as part of China's Great Green Wall appear to grow faster than trees in natural forests, not by a small margin, but by a statistically significant amount, even after controlling for the most obvious confounding factor. The most obvious confounding factor is age. Planted forests are, on average, much younger than natural forests, and young trees grow faster than old trees regardless of how they got there. When the researchers compared trees of similar age and similar growing conditions across planted and natural forests, they still found that the planted forests grew 6% faster. In mixed and evergreen forests, the difference was even more pronounced. The research team's lead author told Live Science that it is unclear exactly what makes the artificial forests different from the natural ones at the biological level, suggesting that the finding creates as many questions as it answers about the long-term carbon sequestration dynamics of China's planted forests, and whether the growth advantage persists, diminishes, or reverses as the planted forests age beyond the 30 to 40-year window where the discrepancy peaks. Subscribe now, because the next section is the one that most coverage of China's afforestation program omits entirely. And it is the part that is most important for understanding what the program has actually achieved versus what it has not achieved, and what it has inadvertently created as a new set of problems alongside its genuine successes. The honest complication at the center of China's tree planting story is water. The Futura Sciences. May 2026 analysis of the Earth's future study put it plainly: the conventional intuition that more trees automatically mean more water is wrong, and what has happened in the 3 North Program Zone cuts cleanly against it. Trees consume water. They draw it from the soil through their root systems and return it to the atmosphere through transpiration at rates that bare desert or sparse grassland does not. The 2025 Earth's Future Study, conducted by scientists from Tianjin University, China Agricultural University, and Utrecht University, tracked the vegetation changes from 2001 to 2020 and measured their direct effect on water distribution across the program zone. The findings were unexpected. Mass greening stabilized moving dunes, reduced severe dust storms, and expanded regional carbon storage as intended, but it also created new pressure on already stretched water supplies in a region where precipitation is measured in hundreds rather than thousands of millimeters per year. In Mikin, in the central north of China, the Royal Geographical Society's analysis of the program found that precipitation had been too low to replenish aquifers at the rate that the planted vegetation was drawing on them, with some groundwater levels dropping by as much as 19 meters. The 3 North Shelter Forest Program's own FAQ acknowledges that in order to maintain vegetation cover in some areas, trees have been replaced and replanted every 3 years. A cycle that is itself evidence of the difficulty of establishing sustainable vegetation in a region whose climate has not fundamentally changed, and which, in the absence of ongoing maintenance and replanting, would revert toward its pre-planting state more rapidly than the narrative of desert transformation implies. The Natural World Fund's February 2026 analysis described what 3 decades of sustained effort has actually produced in China's desertification zones as mixed but meaningful. The desert has not vanished, but in many places it has paused. That alone is significant. China's billion-tree experiment shows what sustained political will, labor, and funding can achieve, and what they cannot. The sandstorm frequency question is perhaps the most instructive single data point for calibrating expectations. China's 3 North Shelter Forest Program page notes that the frequency of sandstorms decreased by more than 20% since 2000, a real and documented improvement. The same sources acknowledge that efficacy has been overstated in some government communications, and that the problem of desertification in northern China has been slowed rather than reversed at the landscape scale, with active desertification still occurring in some areas even as restoration proceeds in others. China's total desertification land area stood at 57 million square kilometers as of 2019, down approximately 38,000 square kilometers from 2014, a genuine reduction, confirmed by the Chinese government's own monitoring data. But the direction of the overall trend has shifted from an annual expansion of over 10,000 square kilometers at the end of the 20th century to an annual reduction of approximately 2,300 square kilometers today. The expansion has been reversed. The scale of the reversal, measured against the scale of what remains, tells you both how much has been accomplished and how much remains to be done. The Taklamakan Desert, China's largest desert, located in Xinjiang, is the subject of the most recent published scientific findings on what afforestation around its edges has actually produced, And the results, reported in a study published in the Proceedings of the National Academy of Sciences and covered by Indian Defense Review in February 2026, are among the most striking in the entire literature on desert greening. The researchers analyzed 25 years of satellite imagery and ground-based observations of vegetation cover, photosynthesis, and CO2 fluxes around the Taklamakan's edges, where China's afforestation efforts have focused on establishing a continuous green barrier around what was previously described as a biological void, a desert so dry, hot, and exposed that it was considered by most scientific assessments essentially incompatible with sustained plant life at its margins under the existing climate. What the PNAS study found was that the Taklamakan has become a carbon sink, not a source. A sink. The planted vegetation around its edges is absorbing more CO2 than it releases, even accounting for the carbon cost of the planting and maintenance work. During the wet season, when precipitation at the desert's edge is more abundant, the greened margin experiences a 5-fold increase in precipitation relative to the pre-afforestation baseline. A finding that suggests the vegetation itself is altering the local water cycle in ways that create positive feedback for further vegetation growth, rather than simply consuming a fixed resource. That finding, that the trees once established begin to generate some of the conditions that make more trees possible, is the mechanism behind every successful large-scale greening project in the scientific literature. And it is the specific finding that the skeptics of China's program were watching for most closely. The argument against large-scale desert afforestation has always been, at its most rigorous, not that planting trees in a desert is impossible, but that it is self-limiting, that without a fundamental change in the water cycle, the planted vegetation will always be in tension with its environment and will always require maintenance at a level that prevents the kind of self-sustaining ecological recovery that makes the project genuinely transformative rather than merely cosmetic. The PNAS finding on the Taklamakan suggests that, at least in some sections of China's desert margins, that threshold, from maintained planting to self-sustaining ecosystem, has been crossed, and that crossed it, the vegetation is generating the conditions for its own continuation rather than depending indefinitely on human maintenance to survive. The broader context of what China's program has contributed to the global system is the number that returns us to where this video started. NASA's finding that China accounted for 25% of the entire global net increase in leaf area between 2000 and 2017, despite occupying only 6% of the world's vegetated land area. Lead author Chi Chen of Boston University summarized the finding in the precise language the data warranted. China and India account for 1/3 of the greening, but contain only 9% of the planet's land area covered in vegetation. A surprising finding, considering the general notion of land degradation in populous countries from overexploitation. China's outsized contribution to the global greening trend comes, the NASA study confirmed, 42% from forest conservation and expansion programs, and 32% from intensive agriculture of food crops. The program that planted 66 billion trees in the deserts of northern China is, by the most rigorous independent verification that currently exists, satellite data analyzed by a team at Boston University and published in Nature Sustainability, responsible for 1/4 of the entire planet's measurable increase in vegetation over the most carefully documented 17-year period in the history of satellite Earth observation. Here's the question that I want to leave you with, because it is the one that the data generates and that the political framing of this story from every direction tends to avoid. The 3 North Shelterbelt Forest Program is the largest human attempt at ecological engineering in history. It has produced measurable satellite-verified improvements in China's desert margins and contributed a disproportionate share of the entire planet's vegetation recovery over 2 decades. It has also created water stress in some planted areas, required ongoing maintenance that reveals the limits of what political will alone can sustain against an arid climate, and produced a growing body of scientific questions about the long-term carbon dynamics of artificial forests that are growing 6% faster than natural ones for reasons that researchers still cannot fully explain. Both of those things, the genuine achievement and the genuine complication, are true simultaneously. And the honest story of what China planted in a dead desert requires holding both of them rather than choosing the version that fits a pre-existing conclusion about what China's environmental programs are capable of. Tell me in the comments whether you think programs at this scale, 66 billion trees, 72 years from start to planned completion, covering 42% of China's total land area in the program zone, are the kind of environmental intervention that other countries facing desertification should attempt, or whether the water stress and maintenance dependency that China's own scientists are documenting make the model less transferable than the satellite images suggest. Because that specific question, not whether China's program worked, but whether what worked in China can work elsewhere, is the most important practical question that the research produces. And it is the one that governments in sub-Saharan Africa, Central Asia, and the American Southwest are actively trying to answer right now. If you want to be here when the next round of satellite data comes in, when the long-term water stress studies publish their full results, and when the penis finding on the Taklamakan is either confirmed or revised by follow-up research, subscribe now, because this story has been running for 47 years and it has at least 24 more to go.